Why AI needs China's supply chain? Everyone talks about the AI race in terms of algorithms and multi-trillion parameter models, but the real battlefield is physical. It's happening inside sprawling data centers, within the fiber optic cables that connect them, and it hinges on tiny components that convert electricity to light at staggering speeds. This presentation is about those components' optical modules and why the entire global AI build-out is critically dependent on a supply chain that runs directly through China. For the past few years, the AI narrative was all about the models. Now, the bottleneck has moved down the stack. Your ability to train and run these massive models is now constrained by hardware, the servers, the GPUs, and critically, the optical modules that allow them to talk to each other. Suddenly, this niche component has become a strategic geopolitical asset, revealing a deep, structural dependency on China's manufacturing ecosystem that you simply cannot ignore. Let's put this dependency into concrete numbers. This isn't a slight edge, it's categorical dominance. Of the top 10 optical module suppliers in the world, 7 are Chinese. The number 1 and number 2 spots globally are held by InnoLight and Eoptolink, respectively. When you're building an AI cluster that requires tens of thousands of 800G modules, the reality is that the vast majority of those components will come from these few companies. There is no alternative at scale. So why can't this supply chain just be moved? Because it's a highly optimized, symbiotic system. Think of it as a global team assembled for one purpose. China is the undisputed world champion of manufacturing, packaging, and testing these modules at incredible scale. But the brains of the module, the sophisticated DSP chips, are primarily designed by American firms like Marvell. High-end lasers come from others. This intricate division of labor, perfected over a decade, is what makes it all work. You can't just build a new one elsewhere overnight. The weakest link in this entire chain is right at the beginning, with the raw materials. The advanced lasers in these modules are built on a special substrate called indium phosphide, or InP. By 2026, the industry is projected to need almost 3 million of these wafers. The problem? The entire world can only produce about 750,000. This 4-to-1 deficit is a massive choke point. It means whoever controls InP supply, a market where Chinese firms are rapidly advancing, has huge leverage over the entire AI hardware ecosystem. Who is driving this insatiable demand? The hyperscale cloud providers. Microsoft, Meta, Amazon, and Google are in a CapEx arms race, pouring billions into their AI data centers every quarter. This torrent of money flows directly to network companies like Ciena, which is now sitting on a staggering $7.7 billion order backlog. When a major supplier tells you some orders won't be filled until 2027, you know the demand is unprecedented. Every new GPU they buy requires a corresponding investment in the network to connect it. So far, we've focused on connecting servers within a single building, but the next battleground is connecting entire data centers across countries. This is the domain of optical transport networks, or OTN, the superhighways of the internet. While Western firms are strong here, China's vast domestic network is built and run by its own giants like Huawei and ZTE. They are now evolving this technology for AI, pushing towards 1.6 terabit speeds on a single fiber to allow an AI model to be trained simultaneously in multiple cities. The industry never rests. While companies are scrambling to ship 800G modules, their top engineers are already deep into the battle for 1.6 terabits. Winning this next round isn't just about doubling a number. It's about fundamental breakthroughs in 200 gigabit per lane lasers, designing DSPs that don't melt under the load, and mastering advanced packaging. The holy grail is co-packaged optics, putting the optics right on the chip. But for the next few years, the familiar pluggable module will continue to reign supreme. This intense pressure has forced a complete change in strategy. The old days of ordering components for a specific project are over. Now, it's about survival. The CFO of a major cloud company is no longer asking for a quote. They're on the phone demanding to lock in production capacity for the next 2 years. This isn't procurement, it's a strategic reservation of future supply. Having a guaranteed allocation of modules is now as important as having the capital to fund the project itself. So, to answer our initial question, why does AI need China's supply chain? Because the competition has moved from the elegance of code to the brutal reality of components. Building the future of AI is no longer about having the best model. It's about having the physical hardware to run it. In this new era, performance is table stakes. The real differentiators are access and resilience. For anyone in this race, mastering the global optical supply chain isn't just logistics, it is the central strategic challenge of our time.